Hey everyone, welcome to the final video of the first half of this series where we've been talking about quadratic equations. Now in this video, we're just going to take everything we've learnt about solving quadratic equations and apply this to a worded question, a type of real-life application question here. Now, we've covered a lot of the actual strategies and processes for solving quadratic equations. So in this video, I just want to run you guys through one question in which we're going to use everything we know, and I'm just going to give you some help with actually approaching these types of worded questions, because these seem to give a lot of students a lot of problems. So I'll try to go through it really slowly and give you the confidence to hopefully be able to approach these types of questions yourselves in your textbooks or in the future. Now we have a question here which says the length of a book is 4 centimeters more than its width, and the area of the face of the book face is 320 centimeters squared. Find the dimensions of the book. Okay, so when starting any worded questions, we want to first just underline some of the key ideas. So the length of the book is 4 centimeters more than the width. It's 4 more centimeters than the width, and the area is 320 centimeters squared. And we want to find the dimensions here. So by the dimensions, they mean we want to find the length and the width here. All right, so let's actually approach this. We want to first draw this book here to actually give us an idea of what we're actually looking at, right? Because these types of questions, we want to take these words, try to visualize them, and then once we visualize it, it makes it a lot easier to work through. Now, let's let our width be x, because both my length and width are unknown, but I'm just going to let our width be x centimeters. So this guy here is going to be x. So that means if our width is x centimeters, our length, our other dimension, is, from the question, 4 centimeters more than that. So therefore our length equals x plus 4 centimeters. So let's write that dimension in here. So one of these is x centimeters and another is x plus 4. Now just for space, I won't write the units because I want to just be mindful of space, and the units make it a little bit messy when we actually apply our quadratic equations. Now our area is 320 centimeters squared. Now, how do we find the area of anything? Well, we get the area by multiplying one dimension by another one here. So let's actually write, from everything we know about area, about the lengths given and widths given here, to actually write some type of equation here to just give us a bit of a kickstart and way to approach this question. So we know that our area equals our length times our width. So therefore, my length times width, that's going to be, I'll do this the other way around actually. Length times width equals the area. So my length here is x plus 4 and my width is x. So my width is x multiplied by x plus 4. And that is equal to my area of 320 centimeters squared. Now, we have a type of quadratic equation here, but we want this in standard form. So first of all, it doesn't help us being in this form just yet because we have to move this guy over anyway. So what we're going to do, we're going to expand this. So my x is going to multiply, my x on the outside, multiplies by both my internal terms, both my terms in the brackets. So x times x gives me x squared. X times 4 gives me positive 4x. And that equals 320. And this isn't in standard form yet. For this to be in standard form, I need everything on the left-hand side equaling to 0 on the right-hand side. I'm going to get there by going 320. I'm going to subtract 320 from that to get me to 0. And I'm going to do that to both sides of the equation. So I'm left with x squared plus 4x minus 320 equals 0 here. This is my quadratic equation. And now I want to factorize this guy here. I'm going to do that by listing the product, the sum, and the factors that I want. So I want a product of negative 320. I want a sum of 4. And my two factors have to add to give me 4, multiply to give me negative 320. Now you can pause the video here if you want to try to figure these out on your own. It's a little bit harder, but I'm just going to give you the answers right off the bat because I've done this question before. Now, my factors are going to be 20 and negative 16 here. So that means my factorized form, I'm going to write this guy up here as a binomial product with these factors here. So I'm going to rewrite this as 0. I'm going to write this as x plus 20 and x minus 16. Okay, so from here, we're just doing everything we've done so far. We are just using the null factor law for both of these expressions. We're trying to find a value of x that makes this expression 0 and this expression 0. That's the basis of the null factor law. We've explained this a lot in previous videos, so I'm doing this assuming that you have watched some of the previous videos and you're comfortable with these techniques. Okay, finally, we are going to solve these equations. So I'm subtracting 20 from both sides here. I'm adding 16 to both sides here. I wind up with x equals negative 20 and x equals positive 16. Okay, now here, if you guys are thinking through the context of the question, this is a measurement question, you may be surprised to see that there are actually two solutions. But one of these solutions is going to be wrong. Let's find out which one. Now, if we have our book, with a dimension of x and x plus 4. Now, we are looking through the context of measurement, right? So anytime we measure at least lengths and areas and things like that, our dimensions or our areas will not be negative. So we can cross this out. If this was correct, then this one would be negative 20, which you can't have. And this one would be negative 16, which you also can't have. So once we get our solutions, quadratics more often than not give us two solutions, but we have to pick one depending on the context of our problem, the context of the question. This is a measurement question, so we can't have negative lengths. We can't have negative 20 as a dimension to a book. You look at any book, you measure it, and you will notice that you're never going to get negative 20 as a dimension for your book. So we are going to be choosing this guy over here. So my value of x is x equals 16 centimeters. So let me write that down here. X equals 16 centimeters. So therefore, I'm going to substitute my value of x into my width and my length. So that means my length is x plus 4, so equals 16 plus 4, which equals 20 centimeters. And my width, we said in the question, well, when we were laying it out, we let our width be just x here. So our width is just the solution to the quadratic, which is x equals 16. So that means our width is 16 centimeters. So by breaking down the question, by drawing a picture, by considering the context of this, making a quadratic equation out of all of this information, we are now in a good position to use the techniques we've been doing all the way up until now. The factorization of the quadratic expression, the null factor law once we have our two binomial products to find solutions. Now the only difference here is one of the solutions will not make sense to the context of our question. We can't have negative lengths, we can't have negative widths, so we pick the positive solution to the equation. A value of x that makes up the dimensions that multiply together to give me the area of 320 of this book face. But that concludes quadratic equations, and we will start to talk about parabolas in the second half of this video series. But thank you so much for joining me, and I'll see you guys in the next video.